Yeah, welcome to today's class. Today we want to look at the circuit diagram for full header. Then after this, we'll go to introduction to data structure and algorithm. So let me not waste much time. Let's get right in. So I'm going to draw the truth table and then the Carnot map and then the circuit diagram. So let's just do that. So I'm going to have three inputs, right? So I'm going to have three inputs. Let's see. Okay, so this is right there. So I have A, I have B, and then I have C in, and then sum, and then C out. That is carry out. Okay, so for my three inputs, since I have 2 raised power 3, that will give me what? 8. So I'm going to have 8 possible patterns. So 0, 0, 1, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. Right? So my sum will be 0, 0. That is 0 plus 0 plus 0 will give me sum 0. And then the carry will be 0. 0 plus 0 plus 1 will give me 1. Carry will be 0. 0 plus 1 plus 0 will give me 1. Carry will be 0. 0 plus 1 plus 1 will give me 2. You can't write 2. You put 0 and you carry 1. 1 plus 0 will give me 1. There is no carry. 1 plus 0 plus 1 will give me 0, and then you carry 1. 1 plus 1 plus 0 will give me 0, and you carry 1. 1 plus 1 plus 1, you give me 1 and carry 1. Right? That is 3. So the goal of this class is to draw the circuit diagram. So let's speed it up. Now with this, I'm going to do the Carnot map again. The last class, the Carnot map for carry that I gave you actually gave us A, B plus A, C plus BC. And then this is, you are seeing 3 AND gates. But I told you that, and this is correct. We can draw the circuit diagram for this. But I want to optimize it by reducing these 3 AND gates to what? To just 2 AND gates. That will now give me 2 half adder plus OR gates to give me a full adder. So I'm going to optimize it. So I will use a different pattern of the Carnot map to extract 2 AND gates. That's what I want to show you in this class. So already we know the sum. I taught you in the last class. Sum equals to what? A exclusive or B exclusive or C. That is the sum. So what we need now is what? The carry out, which is what? C out. That's what we want to achieve. So let's do the Carnot map for this. So I'm going to do this. And then I'm going to do this. So let's just do this. And then this. So this. C out. So I have my A. So 0, 1. So here will give me 0, 0. This is BC. BC in, right? BC in. So 0, 0, 0, 1. Then I told you, gray code. I have to switch the position. Instead of 1, 0, I'll put 1, 1 here and I'll put 1, 0 here to allow us have 2 good neighbors, 1 bit changing. And then we'll create a circular form. So 0, 0, 0 will give me, we are looking at the carry out, so will give me 0. 0, 0, 1 will give me what? 0, 0, 1 will give me 0. Then 0, 1, 0 will give me 1, will give me 0. 0, 1, 0 will give me 0. 0, 1, 1 will give me 1. 0, 1, 1 will give me 1. Now 1, 0, 0 will give me 0. 1, 0, 0 will give me 0. 1, 0, 1 will give me 1. 1, 0, 1 will give me 1. 1, 1, 0, 1, 1, 0 will give me what? 1. 1, 1, 1 will give me 1, 1, 1 will give me 1. So this is our carry out. Now, the last class, what I did was to sum these adjacent numbers like this, right? And this, and then this. But this time around, I'm going to take them one individually. So this. So for this, that is A prime, B, C, plus this one. This is A, B prime, C, right? Plus this one. This is A, B, C, plus this one. A is A, B, C what? Prime. So that is what we've derived from this Carnot map, the equation. Now, if you look at this, I can reduce them further by looking at this. What is common between this and this? C is common. A is here, A change. B is here, B change. C is here, and C is the same thing here. So I can do this. A, B, plus A, B prime into bracket C. Then this place. What is common? A, B is common. C change. So A, B, C plus C prime. Now this one is the same thing as saying C plus C prime equals to what? 1. So 1 times this will give you AB. Now, if you look at this place, my last class that I taught you, A prime B plus A plus B prime is the same thing as A exclusive of B, right? Because if you look at the circuit diagram of exclusive or, when you expand this is what you are going to get. So this place then becomes A exclusive of B, C plus this is 1, right? This is 1. So this one becomes AB. So this is the final output. Now, based on this, we are going to draw a circuit diagram with the sum as this. Because if you look at this sum, if you have to find the diagram, the Carnot map for this sum, is going to give you a checkerboard, which we did in the last class, right? So based on this and this, we are going to draw our circuit. Now I'm going to clean this. So let's clean this. And then we'll bring sum, right, equals to what? A exclusive or B exclusive or C. And then this is our carry. So this one is what? C. This is C out, right? Our C out. So let's draw. Now, since A exclusive or B, so we'll do exclusive or like this, right? And then we have this, and then this is A, and then this is B. And then the output of this exclusive or will now do another exclusive or with C. So we have C. So this is C in, right? This is C in. Because this one is C in, right? So this is C in. Now it's going to do exclusive or. So that means we have another exclusive or here. So this one will go in here, and then this one will go in here. So this one will give us sum, right? So that's what we are getting. Now let's come. So this is the part of the sum. So this A exclusive or B, the output will go into another exclusive or with C in. Now let's do the carry out part. So the carry out part, we're having two AND gates. This AND gate, this another AND gate, then OR gate. So I'm just going to draw one AND gate. So let's clean this part. Then I'll draw another AND gate. Then this is plus OR gate. So I will have one OR gate like this. So this is what? C out. So this is C out. So the output of this will go here. Output of this will go here. Then, so this is AB, and then this is C. So for this one, exclusive, A exclusive or B, already is this one. This is the output. So it's going into one AND gate. So this from here will come into this AND gate. Then C. So this C will come here, right? Then AB. So this is AB. So I will have this come here, and then this will come here. So they are not joining. I don't want to cough it. Just note that. So this is our output. So this is our full adder. full adder. So that tells you two half adder. So this is, so you can take this one as one half adder, and then this one, right, as another half adder. So that is that. So the output of these two hands will go into this OR. So now let's test. Let's test if this drawing is accurate. We have, let's take, let's test. Let's take this second line. So this second line, A is what? A is 0, B is what? B is 0, and C is what? C is 1, right? Now you know exclusive OR, if the two inputs are the same, the output will be what? 0. So the two inputs here are the same, so the output here is 0. So if the output here is 0, it means that the input here is 0. Then this one is 1 going here, so this is 1, right? Then this one will come here. So if this is 0, it means this place is 0. Now this is 0, this is 0. So this is 0, this is 0, right? Now let's check. So this is 0, this is 1. Now the input to this exclusive OR are not the same. So the output will be what? 1. So sum is 1. So for this one, right, sum is 1. Why this one? 1, 0 will give us 0. 0, 0 will give us 0. So 2, 0 output, C out is what? 0. So that is it. That is correct. Now, let's test with the last one. This last one. Everything is 1. A is 1, B is 1, C is 1, right? So we are having sum as 1 and the carry out is 1. So let's check. So this is 1, this is 1. You know, they are the same. So the output here will be 0. So this is 0. But this is 1. So this place is 1. So the output of this one will also be what? 1. Sum is correct. Now, this is 1, this is 1. So this place will be 1. This place will be what? 1. So 1, 1 will give you here as what? 1. Now this is 1. So if this is 1, this place is 1. But this is 0. So this place is 0. So 0, 1 for AND gate will give you 0. But 1, 1 for AND gate will give you 1. 0 and 1 into OR gate will give you 1. So that is also correct. So if you go by that, this circuit is correct from this AND gate and then from this truth table. If you want us to test further, you can test the remaining one and you still get the correct output. So what is this telling us? That if any mathematics can be reduced, if you can obtain a truth table for any mathematical equation, we can actually create a technology for it. That is it. So you can see what we have been doing, how to convert voltage into binary using transistor. And then once you convert the voltage into binary, you can find pattern and then use it to create a circuit diagram for technology purpose. So you see, it is interesting. Now that we have come this far, we can now move into data structure and algorithm. So data structure is how you organize the data. Because what is data? Data is actually binary pattern plus agreed interpretation. That's what we've been doing. So how do we organize this data? Then the operation that will act on this data is what you call algorithm. So based on that, you now get your output. So that is the next class we are going into. So 2 more topics: data structure, algorithm, and complexity, meaning which of the implementation are we going to pick? Just like what we did here. I gave you 2 Carnot map for carry out. One will give you 3 AND gates. The other one is giving you 2 AND gates, but both are correct. So optimization is that I actually optimize it to give me the 2 AND gates, right? So that is what we are going to be looking at. So till we see in the next class, don't forget to subscribe if you have not done so. And do not forget to give me a thumbs up if this makes sense. Bye-bye.